Welcome again to another episode of Empower Apps. I'm your host, Leo Dion. You can find us on Apple Podcasts and Google Play, as well as Spotify. EmpowerApps.show is our website. Today on our show, we have with us Anne Cahalan. Hey, Anne.
Hey, how are you?
Good. Thanks so much for coming on the show today. I was really glad to see you at CodeMash back in January and schedule a time to talk about a topic I'm really interested in, which is code quality. So you gave a talk on Vapor at CodeMash. How did that go?
It went pretty well. We accomplished everything in the workshop that I had hoped we would. I always worry about those not filling enough time or running way over, but we managed to get a small web app, note-taking web app up and running for everybody in the time that we were given, and I call that a success.
What was the biggest friction with getting people to develop using Vapor?
I think the biggest point of friction is just awareness that it exists and that it's actually ready for prime time, so to speak. I see a lot of questions online of people who are especially interested in Vapor and they still think it's kind of a toy or a proof of concept, not realizing that all of the in-car electronics or in-car communication business on Mercedes-Benz's, for example, runs on Vapor. And that there's a couple of other like large-scale, heavily enterprise organizations that are supporting their apps with Vapor.
Yeah, exactly. I'm still surprised how skeptical people are.
Yeah.
We had Tim on the show a couple of months ago, and people are not aware of how much it's used in production.
Yeah.
And I think Apple's kind of slowly moving in that direction. I know they have a lot of stuff probably that's built on Java. So I wouldn't be surprised if they're slowly moving to Vapor as well for their backend services.
Yeah. Well, the biggest selling point, I think, right there compared to Java is Vapor runs just as quickly as Java, which means it's faster than Node by a lot. But it does so while taking up so much less space.
Right.
So if you're paying for server space or some sort of cloud platform, if you run it all in Vapor, all of a sudden you're getting a discount. You don't see a performance change, but you do see a bottom line change that's pretty dramatic.
Yeah, exactly. I've had nothing but a great experience using Vapor, and I'm really looking forward to trying out some of the new stuff in Vapor 4 that's in beta right now. But as far as like the niceties of Swift having that accessible on the server is really great. And I kind of feel like it's at a point where Node may have been like 10 years ago, where it's got a strong community behind it. It's just a matter of getting more of it over to production.
Yeah, but I think it's making a case for itself pretty well. So that's helpful.
Yeah, exactly. So today we're going to be talking about code quality. What does that actually mean? Perhaps we should start with that. What's your definition of code quality?
My definition of quality code is code that is easily maintained, code that's easily onboarded to, and code that's easily understood. Everything about code quality should be focused on ease of use, whether that means ease of opening up a file and understanding what it's doing and where your data is going and how it's moving through the application, or whether it's ease of extending what your code is doing, making it do new things and go in new areas, or ease of figuring out what went wrong when a bug pops up, when something's going sideways, ease of being able to figure out where the path has gone off the rails a little.
Okay, so when you say ease of use, you mean like as far as you can see the workflow of the application, but then also ease of maintenance, it sounds like, to where it's easy for any developer to pick it up and start making changes or extending it or bug fixes.
Exactly. The other talk I gave at CodeMash was code quality, specifically making the argument that sometimes you need to write more code instead of always being on this quest for writing less code and trying to do things in smaller and smaller spaces. I really dig into the difference between easy and hard and simple and complex. Easy and hard are relative measures. Simple and complex are things that you can actually quantify. A lot of linters have, for example, a measure of cyclomatic complexity, and you want to try and keep that down.
Define what that means exactly. I know what you're talking about.
Cyclomatic complexity. It is basically a measure of the number of paths through a function that your data can take, your code can take. So if you think, for example, of a function that takes one parameter, evaluates one thing about it, whether it's true or false, for example, and then returns that Boolean. You have very low cyclomatic complexity. It's doing one thing. You have one potential route through there, maybe two. If you think of something like a switch statement that has 53 different cases in it, and each of those cases has an if statement nested in there on what it's doing, well, now your code can take a lot of routes through there. And that cyclomatic complexity is just the number of possible paths through the code that that you could take.
And like that even makes it even more complicated when you start doing unit testing.
Oh, yeah.
And things like that, to where you want to break that apart, like refactor it either into separate functions or even better into separate protocols and types.
Exactly.
It can be easier tested.
If there's 53 possible outcomes from one method, you're going to have to write minimum 53 tests. Maybe 54. What happens if you don't get any of those? Maybe there's error cases you have to handle on top of that.
Right.
So it just gets to another thing that, like, good quality code, in my opinion, is easily testable because it's easily broken down and it's easy to evaluate. What do you want? What do you not want?
So it sounds to me like one of the important reasons behind code quality is the amount of time and therefore the amount of money you're going to have to spend in order to extend and maintain this piece of code.
Exactly.
Our sponsor this week is BrightDigit. BrightDigit is my company, and we specialize in helping businesses build apps for the iPhone, the iPad, the Apple Watch, and the Mac. I've been building apps for iOS for almost 10 years now. We have an opening for new projects. If you are a company who might already have developers but need help building something for any of the Apple platforms, send me an email and let's see what BrightDigit can do for you. Contact me personally at leo@brightdigit.com. That's leo@brightdigit.com. And let's see how I can help you and your business. Are there good reasons, though that is a major reason, are there other good reasons to maintain good code quality?
Yeah. All of us live in the dream of someday, like, running off to Fiji or something like that. Nobody's going to stick around in a code base forever. Your attention's going to wander. You're going to be cycling in new developers over time. Having easily understood, good, clean code means that newer developers, the sort of on-ramp is much shorter. They can understand what's going on in the code base. They can formulate smarter questions about it because they can see quickly what it is they don't understand instead of having it buried in a couple layers of, I don't understand what syntax is doing. I don't understand why all this data is all over the place. And also I don't understand what it's doing. Those sorts of things can really slow a project down. And the other thing is, honestly, it's a concept I like to call code rots. Code rots over time. What is a clean and good and acceptable approach today might look really dated and kind of messy tomorrow when we have new frameworks, we have new APIs, we have just new paradigms of thinking about how we're going to move through our code.
So a good example of that would be, like, especially all the talk about Swift UI, would be like moving away from a delegation pattern over to more of a subscriber publisher model.
Exactly. If you've ever looked at a project from, say, maybe Swift 2 or 3 and looked at it now, you can see that, like, we were doing cool stuff. We were doing stuff that we thought was fancy and amazing and cutting edge. And now we look at it and we're like, we got better ways of doing that. We've got better ways of thinking about this problem. Next week, we're going to have future versions of Swift down the road. We're going to have even better ideas than the one we have now. If we keep things simple and clean now, updating them will be a lot easier and a lot faster.
So that brings up a really good question, is with new APIs, at what point should you look at maybe not so much overhauling, but maybe starting to upgrade some of that older code over to using newer APIs or newer protocols and models?
The easy and hard answer to that question is when it makes sense to.
Yeah.
If you have something that's working and is an area of your app or your code base that isn't facing a whole lot of changes and is kind of structural, then maybe you let that stay where it is in the format that it is until you have a lot of bandwidth to start poking at it. But if it's an area of the code base where you're making a lot of changes, where you're going to be extending it, trying to get this part of your app to do a new thing, adding features, if it's an area that's become buggy or hard to understand, then maybe it's time to start taking that apart. It's actually a project I'm on right now has a code base that's been around for a long time. And there are definitely parts of it where I call it that's our emotional support Objective-C. We have to keep it there because messing with that is going to be a bigger problem. But there are also areas where we're specifically looking at, like, this has been around for a long time, but it's an area we're working in now. We've come back to this and we're extending it, trying to get it to do new things. We've found an easier and faster way. Now is the time to not just sort of paper over that or like cross our fingers and hope interoperability saves us, but to actually take the time to make those refactoring changes.
And what's nice is, like, in the environment we work in, Apple is usually pretty good about not burning old bridges.
Yeah.
In the sense that from Objective-C to Swift, like, we at least have bridging files and things like that so that we can do some of the stuff in Swift and Objective-C and some of the stuff in Objective-C and Swift. With Swift UI, we have the UI hosting controller and UI view representable that allows us to have that bridge between newer ways of doing things and older ways of doing things. So at least you can slowly transition off of older APIs and older patterns.
Yeah. But also, you've got to be... That's why I said it was the easy and the hard answer is it depends, because you have to be thoughtful about it. That can give you a crutch or an excuse to be like, well, this works, so we're just going to keep papering over it because it would cost too much in either time or actual resources to fix it. How much time and resources are you spending sort of working around it, dealing with, we're not going to make these changes, so we're going to have to go all of this far out of our way to make something work, make something be backwards compatible to a thing that we think is not worth updating.
So we may as well get into it. We talked about low cyclomatic
complexity.
Oh, man. Let me try again.
It's a tongue twister. I practice saying it.
It is. See, I read it, but it doesn't mean I have to say it. So now it's like I have to actually say it. Low cyclomatic complexity. We talked about that. That's a pretty obvious one. There's some other typical things like line length or file length. Those are decent indicators. I run Swift lint and Swift format all the time, so I totally have seen these 100 times. What are some other ways where you can see or know that you have good code quality, or what are some things that you should be looking out for besides those?
One thing that I like to look out for is something that someone told me when I was first learning Objective-C was that your code should read like sentences. There shouldn't be anything convoluted or strange. You should be able to read it each file almost as if it were a chapter in a book that's telling you a little bit of a story about what your data is going to be doing in this particular file, in this particular path. That's a little woo-woo, but it still, I think, works, because what you want to be able to do, and the whole point of writing clean code, of writing quality code, is that you can understand it. You can understand it whether you're new to it. You can understand it whether you wrote it all yourself, handcrafted, and then walked away, had dinner with a friend, went on a short vacation, pet a dog, came back, and now you're looking at this code that you wrote a month ago in a completely different context while you were paying attention to the very specific business rules of that particular moment, and remind yourself what's going on. And it's much easier to do if you have written things in a descriptive enough manner and used given yourself as much information as possible within the code that you can come back to it and remind yourself what's going on.
Do you ever have the incident where you go back to old code and you're like half embarrassed by it and you want to rewrite it? And then when you rewrite it, you realize you probably did it the best way you could?
Yes, I do that all of the time. And I guarantee you every time I look at Xcode and say, what idiot wrote this, and hit that little authors button, I'm the idiot that wrote that. Which gets into actually something else about code quality that I think is important. And that's the concept of empathy. Having empathy for the people who are going to come to your code after you have written it. And those people could include junior developers who don't have the experience that you have. Those people could include people who are new to the project and don't have the context that you have. And those people could include you, future you, who, like I said, pet a dog, had a couple of drinks, went to the zoo and looked at an elephant. And now you're back looking at this code and you are no longer in the context and in the moment you were when you wrote it. You've sort of shed a bunch of short-term knowledge that was really important at the time, but not something you needed to carry on with. And now here you are back in this code. Have you written it in a way that is kind to yourself? The first chapter in Swift for Good is by, hold on, I wrote it down, Dave DeLong, and it's on API design. And he really gets into the idea of a kind API. Like, what is an API that is kind to the people who are going to be consuming it by being easily understood, by being well documented, by giving them what they want in the form they expect it to be in? Those kind of empathy things, those kinds of kindness things, I think we need to make sure we're paying attention to in our code. Again, because it affects other people and we want to be nice, but also because it's going to affect us later.
Yeah, Dave's a really good guy. He did a good talk at i360 Dev on the laws of magic in relationship to programming. And yeah, I find that whole book, the Swift for Good book, we had Paul on talking about it. Seems like there's a lot of great articles in that book that are worth your time, for sure.
Yeah, I've been working my way through it very, very thoughtfully because everything in there is so good and is kind of layered.
Yeah. So the other thing I was going to mention, with the talk I did on beginning Swift over in CodeMash, one of the things that I find quirks in Swift that I actually like, that came from Objective-C, is the idea of argument labels and parameter names, how there's two different things. And I was just thinking about that when you were talking about how your code should read like sentences. I think people look at that and they're like, well, I don't want to use that when I create my function because it's weird to have both the argument label and a parameter name. But if you use them really well, it actually helps your code become more readable.
Exactly.
And it's like a really useful tool. And some people, I think, like as programmers, we want to be as efficient as possible. So, we label things I and X and A and B because
we're in a hurry.
Efficient. Right. But I'm all about making your function wordy to the point where it makes exact sense of what it's supposed to be doing. And that's where I find argument labels really useful.
Yeah, they're so great. And having those argument labels, when you think about where that code, like the call site of that code, where that function name is going to be invoked and with what parameters, then you have written it as exactly as a sentence. You can read it exactly, update, whatever. And that whatever is, maybe gets referred to within the body of the function differently, but you can just write out exactly what your intention is. And then when you come back to it or when someone else looks at it, they can see exactly what it is.
Right, exactly.
This kind of feeds into I wouldn't call it a war on ternaries, but my heavy suspicion of them, because you have this sort of fancy operator that has the ability to do something quickly, but not necessarily be understood quickly. And I think there's a trade-off whenever you use a ternary between your speed in this particular moment when you're writing it and your speed later when you come back to it and have to remind yourself which end is the true end and which end is the false end and what's going on here. Yeah.
I don't know if I feel that strong about ternary operators, but I understand where you're coming from.
Yeah.
Ternary, for those who don't know, assuming I'm pronouncing that right, is the question mark colon, to where the first part of that is a Boolean, and then the second part is what is the result if true, and the second part, or the last part being the false if true, if false result. The thing is, I don't think I use them as much in Swift. I feel like I don't need to in a lot of ways, especially with as much of the testing being if variables are nil. So I end up using a lot more iflets or guard cases or guardlets and things like that. So maybe that's part of the reason why I don't see them as often in Swift. But what I do see, and I'm curious your opinion, is the coalesce operator. Do you feel that strongly about that?
I feel a little less strongly about that, but I still feel that if you're going to do something like that, don't add any other complexity to it. Don't instantiate something within nil coalescing. If this thing doesn't work, then make one of these instead. Pull that out into some kind of variable. Give yourself the least amount of complexity at the time. Because we do have optionals, I almost feel like that nil coalescing is Swiftier and sort of follows a pattern that exists in the language that within the context of, you're looking at Swift, you know what you're dealing with. If you have a basic familiarity with the sort of idioms of Swift, that's a thing that is a little less of a speed bump when you're quickly running through code. But that could be a bias I have because I'm more used to looking at them.
Yeah. What are some other bad code smells, so to speak, when you look at someone's code?
when someone's code, one thing that always drives me bananas when I see it, and I try to never do it myself, dependency injection is a fantastic thing. It's super great, but make sure you are, when you are injecting something, not instantiating it too. Like, make this view with these 7 properties. Make sure that you have pulled those out so that a person who is looking at this for the first time, or when you come back to it, you only have to think about one thing at a time. I've made an image, I've made a button, I've made a label, and I am putting this button, this image, and this label in this view. I'm not making a view and then making a button and then putting it in and then making an image and then putting it in. I have an example in my code quality talk where I try and reason through 2 different lines of code, and one exactly follows a story. I've made a button, I've made a label, I'm putting them in this view. And the other one I describe as drunk me telling a story. I made a view and then, but there's a label, and then I put that in there, and then, anybody who's dealt with drunk me knows exactly what I'm talking about.
So are you talking like multiple, I don't know what the right term is, but like having multiple generations being instantiated?
Yeah, all in one call site. Yeah.
Okay. Because I've done the case where I use like an optional parameter in the constructor of some protocol, and then like basically have a default in the actual instantiation. So that way, for testing purposes, I can customize it. Yeah. But 99% of the time when you actually run the app, you use the actual instantiated type. That's okay. But however, like if I don't instantiate inside the second generation or whatever thing that's contained within that thing, I guess, so to speak.
Exactly. Each line of code that you write should be one thing that you are thinking about, or at least as few things as you are thinking about, need to think about as possible. Apps are complicated. The stuff that we're doing is complicated, and anything we can do to make that simpler or less complicated or easier on ourselves is going to be to our benefit in the long run.
What are some other things that you find in Swift? Because I've heard a lot of criticisms, for instance, of enums, especially the way enums are in Swift, and switch case statements. Are those okay to use? Are there issues that come up with using those in Swift?
Well, first of all, this is one of the code quality things that really informs how I think about code, is that there are very few, I should say, absolutes in the world. You have to think about everything, and you have to be thoughtful about the choices that you're making, and not follow rules simply because they exist, but think about what the logic behind that rule would be. So switch statements are a good example of that, because like we even talked about this earlier, we were talking about cyclomatic complexity. That's a lot of times where that Swift lint warning is going to get triggered if you have a switch statement that has a bunch of cases in it.
And a bunch of associated values.
Yeah, and a bunch of associated values and things like that. But if you think in terms of how can I streamline my reasoning about this code? How can I streamline my ability to understand what it's doing? How can I make it easier for me later, or people in the future, other people who don't even know me, to understand this code? A switch statement actually works pretty well, because you can hop through it very quickly. It's sort of well organized and contained. Like you said, if you have an enum with a few number of cases and you are really just doing one thing per case, then a switch statement, even if it trips up your cyclomatic complexity warning, might actually be the cleanest possible way of doing that. It's why I say, like, you've got to be thoughtful about what are the reasons for the rules, and why are you following them? Are you following them because somebody said so, and because you want to make the little like warning shut up on on Xcode when you run SwiftLint, or are you doing it for a good reason?
Yeah, and we'll talk about shutting up warnings later on, because I have plenty of thoughts on that.
No, yeah.
How about, I'm just going to throw a couple other things at you. Generics.
Generics is another one of those, like, use judiciously. They're a great handy thing, and they can make your code a lot more extensible, a lot more, in some cases, readable. But make sure you have a reason. Make sure that this thing is generic because it needs to be, and not just, we have this hammer, so we're going to use it. Or the sort of trap that I have fallen into in the past, where I learned how this hammer works, and now all I can see are all of the nails I could beat down with them.
Yeah, I totally agree. And then I'm just going to ask one last one. Extensions.
Extensions, I love. I think extensions are your friend when it comes to readability and to understandability, because it breaks down what you have to think about in any particular moment when you sort of gather together. I really like extensions for protocol conformance. I think that's the greatest thing that Swift has done, is that pattern where we put an extension with our protocol conformance at the bottom of the file and sort of gather everything that relates to that protocol in one spot. Now, when something goes sideways with that protocol, or if you don't understand what it's doing because you're new to it or it's been a while, you know exactly where to find it. You know where to look, and you've sort of encapsulated your code quite nicely and in a very like sort of bite-sized understandable chunk. And I think that's really interesting because thinking back to some old Objective-C projects that I have been on, I think we always wanted that. A lot of the sort of well-formatted, easy to understand, gigantic Objective-C files that I've had to look at all have broken down into like mark this stuff, mark that stuff, used pragma marks in the way that we sort of use extensions in Swift. And I think that just shows that like there was a portion of the thoughtful about code community that wanted something like that.
One of the complaints I've heard is that it can sometimes hide functionality of a specific class or struct if it's in a separate extension, if that makes sense.
Yeah, it definitely can. That's the sort of risk for it. But knowing that exists, I mean, I am a fan of keep them all in the same file. Make sure that as you like scroll through and look at something, they're easy to find. I wouldn't put an extension unless there's a very, very good reason for it. I wouldn't put an extension in a separate file.
Yeah. I think what we're kind of getting at is like it really depends on the case. And for me, like what makes it easy for me to want to use extensions is when I have that UI table view controller or that UI view controller with like, I have to implement data source, I have to implement the delegate. I also have to implement some of my own custom protocols that I might be using.
Yep.
And you end up with this like 500, 800 line piece of work. I'll just call it that. And at that point, it's like it makes total sense to start using extensions. So I split the file up into, here's the implementation of data source for that table view controller. Here's the implementation of my custom protocol in that controller, and so on. And I think that's where like extensions make a lot of sense. Of course, there's that. And then the other one being like when you have some stupid 2-line piece of code that does something to a string that makes sense for an extension. I think that's what it sounds like to me, is like generics are great, but just don't overdo it. Don't over-engineer, which is what we oftentimes do. And like don't oversimplify things to the point where they're not very flexible.
Yeah. I think the sort of enemy of clean code is thoughtless code. Sort of low quality code tends to be code that you didn't put a lot of thought and consideration into, possibly because you were following some sort of rule kind of blindly, possibly because you learned a new trick and you want to try it on everything, possibly because you're just in a hurry and you're like, I can do this. Like my approach to something I don't know how to do is to do it the messiest way possible and then clean it up after I have gotten it working. And I think there are definitely people out there who get to the point where something's working and high five, it's working, let's go. Right. And sometimes that's external pressure. That's, a manager is breathing down your neck for a deadline, or you don't have the bandwidth for some reason to actually go back and clean up what you is not the best.
I think I'm going to say something. I think messy code is better than over-engineered code. Because in this sense, at least messy code, you can clean up. Over-engineered code, it's like a really tight knot. You end up having to untie a ton of knots in order just to get back to something that can be fixed into a healthy, good, architectural pattern, if that makes sense.
That makes perfect sense. And that's definitely true. Part of the genesis of my Code Mash talk on writing more code to write better code, I was working with some guys who were great developers. I don't throw them under the bus. They're very smart and very, very great, good developers. I don't know how else to say it. But they had just come off a project that was one of those, we don't have time to do this clean, so we're going to do it messy. All of our files are going to be 700 lines long.
Right.
Everything's, this is an exaggeration, but just one function in app delegate that is run the app. And it's 4,000 lines. Wasn't quite that bad, but that was the sort of style of project that they were on, and they were under a lot of deadline pressure. And as a reaction to that, the project that I was working with them on was this endless quest to cut down the lines of code as much as possible, sort of for its own sake. So if you could do something in 8 lines of code, you could probably do it in 6. And if you do it in 6, you could probably do it in 4. And then you end up with one line of code that is doing 17 different things, and you can't look at quickly and understand. You can't test very well because it's doing a bunch of things. And trying to onboard onto that next project was really a struggle.
Yeah. Yep. That makes total sense. Before we get into some of the third-party tools that you can integrate into your code, kind of like the CI type tools that can check your cyclomatic complexity. Yay! It's always good to have a person actually look at it, especially a person who might end up having to maintain your code. And that's where we get into something like code reviews. And we had Kyle on a few months ago talking about that as being part of the CI process. Isn't just the automated part that Jenkins or Travis will do, but the part where you'll have someone actually look at your code before that pull request is merged. What are some good practices, both for the person who's submitting the code to be reviewed, well, let's start with that. What are some good ways to prepare a good code review?
One thing I always do is before, at my last commit, where I'm all right, we're ready to put this up for a PR review, I like to take a minute and just step away completely, create a hard break, however that works for you. I work from home, so I will go make myself a cup of tea and then come back to the computer, go check your email, go do something, make some sort of hard psychological break in between your last commit and actually putting up the pull request. And then when you get back to your desk, when you get back to your computer, take one more look. And that's why I think that hard break is important. When you take one more look, you have now separated yourself from the context of, I wrote this code, I've been struggling with it for hours, it's finally doing the thing it's supposed to do. Here's all of the 17 different things I was keeping in mind while I was writing it. Now those are all gone. You've sort of cleared up a little bit. Does this code still make sense? Are there any changes you would make to it? Do you see anything where you're looking at it and you're I could have done that a little better? Now's an opportunity to take that final polish. And after you've done a final polish, or if you look at it and you're yeah, no, this is as good as it's going to get from me. When you put up the PR, I'm a big fan of having PR templates if you're working on a team where you have had a conversation with your teammates on what do you want to be given when you pull down a PR to take a look at it. Link to the Jira ticket, whatever tracking you guys are using is always helpful. What kind of context do you need to know? What changes have you made and why did you make them? My current team has a line in our PR template for regression risk. What have you risked by doing this? A lot of times we don't think about that in the quest to accomplish the thing that we're trying to do. What could we have possibly broken along the way, or complication have we introduced? That just gives you one last second to think about it. I'm a big fan of screenshots because I think it gives you two things. It gives you one last chance to run the code, make sure it actually does the thing you say it's doing. And you have photographic proof of that now. And also it provides a little bit more context for the person who's reviewing it. The value of a code review from another human being is that they don't have the context that you have. They may be called upon to look at this code when there is a bug in it, or when it needs to be extended, or when it needs to be understood in the context of something else they're doing. So having another human there to actually look at it and think about it, can they get into what you were trying to do? Can they understand everything that you were trying to accomplish? Did the decisions you made while you were writing this code make sense to someone who was not living in that code for however long it took you to write it? Those are some sort of good PR practices for the person who has written the code to put it up.
So I know GitHub has PR templates. Do most third-party Git services do that as well?
Yeah, that seems to be a pretty common feature. I know, like you said, GitHub does that. GitLab has them available. Don't have a ton of experience with Bitbucket, so I don't know, but I hope so. But even then, I mean, a sticky note with the 5 things that you guys want to have, your team wants to have on a PR request also works. I think we rely on, well, we can talk about this when we talk about automated tools, but don't try and over-rely on a tool when just, being thoughtful and doing something, having a good practice will save you.
Yeah. When you do a code review, you're talking about, let's say there's a piece of code that's just hideous.
Yeah.
It works, but it's hideous. You know it. let's say you have a due date for a code review and you have a piece of code that's just absolutely hideous. Can you just say, hey, guys, like, look, this piece of code here is just, it's not ready. It's not fully baked. Could you please not look at it? Or like, are there patterns or practices for something like that?
Sure, certainly. Tag PR or just let it be known that this is a work in progress, that you're still working on it, but you want to have eyes on what you've done so far, either to make sure you're not going down a rabbit hole or because, like you said, there's a deadline. It's not quite done yet, but here we can get the process moving. And then also I try and if there's any bit of code where I'm looking at it and I'm like, I know there's a way to do this better. I could spend the next 6 hours banging my head up against it, or I could just put up this PR now. Call it out.
Right.
Call it out. Every one of those tools has a comment feature. Just highlight your bit of code and be like, I don't think this is the best possible solution, or specifically, here's what I don't like about it. Let me know if you have a better idea. It's a collaborative enterprise that we're doing here. We're working together.
Right. I think like the fear too is like they're going to tell you stuff you already know is wrong with your code, and you'd rather have them focus on the parts of your code that you think are finished, that you'd rather have like an actual set of eyes focusing more on that, if that makes sense.
Absolutely. And if you call that out and say like, you know what? Here's what's ready to go. Here's this bit that I'm going to keep poking out with a stick and see if I can make it better. That saves everybody's time. It's wasting their time to look at something that you're going to change as well. Gives them the opportunity to skip over that and be like, all right, I'll get back to it when you lift the veil over there.
Right. So what are some things that managers can do to facilitate better code quality and better code reviews?
Well, the first one, I think everybody's sort of familiar with the phrase a fish rots from the head, but the opposite is also true. Managers are in a position of authority and responsibility. They can set an example. They can make sure that everybody is given enough time to write good and clean code and can like look at what deadlines are and what the risk of those deadlines isn't necessarily just not meeting them, but also pushing garbage code because you have to sort of shut down at a certain point to keep things moving. There's a quote, I'm trying to remember who it was from, is, Benjamin Franklin or somebody like that of that era. I'm writing you a long letter because I don't have time to write you a short one. This idea that it takes more work to write a short letter than a long one to just like throw all your ideas out there and whatever. It takes a little longer to write cleaner code. Make sure that your team has the time to do that. Make sure that the team has the time to do things like address tech debt. Like I said, code rots. You made a beautiful, beautiful wedding cake and then left it on the counter for a month and a half. It's going to be a mess when you come back to it. Make sure people have time to do things like cleaning the fridge, go back and see what's not working or what could be cleaned up and cleaned better. Those are things that managers have a little more control over than the coding team itself does.
Could there be a challenge with that, especially with the manager who hasn't been coding very often?
Yeah. If they don't have that background to have the experience of having written clean code or written garbage code, or this works and we're in a hurry, so we're just going to ship it. And then, a month later when it comes time to extend it, or when we find a bug in it, it's much more of a nightmare to unravel. If you don't have that experience, you cannot understand that experience. And that's just the way of the world. But what you can do is listen to your developers. And when they're pushing back on something, if you're asking for, as a manager, I need these like 3 little changes that seem really small, and for some reason the team is telling you it's going to take a month, don't argue with them, just ask them why. And what you may find out is that, they're tiny changes, but we haven't had time to address tech debt in this area. They appear to be tiny, but there's this hidden complexity in our code base that are going to make them make it more difficult to do. Listen to them, ask those questions, and then again, it's all about time. Maybe what you need to say is, okay, this is kind of ideally, I can't imagine a manager ever saying this. It would be beautiful and the angels would sing. But the manager will say, all right, we're going to put these 3 tiny features on hold for a month. Take this month to refactor, to clean up, to address tech debt, to, address the mess that we made trying to hit a deadline last week. And then the stuff that we do in the future will all move faster.
Right, exactly. That makes total sense. And I could see how somebody who's a manager is in a tough bind, like
Yeah.
being able to allocate that time and make that argument to those that are, their superior, so to speak.
Yeah, it all rolls downhill, right? The pressure is coming to them from somewhere else. But I mean, a good manager is supposed to be a poop umbrella, as they say, where like it comes down on them and they deflect it away.
Right.
And turn around and go up and be like, hey, argument is always there that we are going to either spend a lot of time now on this like tech debt work that seems low value because there's no dollar value associated to it. Or we can spend much more time, probably more time than we would have spent just addressing the tech debt, working around that giant mess that we made. And that is going to cost us money to release new features. All of those new features get more expensive because they're going to take more time. They're going to be harder to do. They're going to be riskier.
Yeah, exactly.
One of my coworkers used a phrase in a meeting yesterday that I love and I'm going to steal. And it's like, don't take out a payday loan in tech debt.
Yeah, but that's just that temptation is so much there, especially to folks who don't understand the code.
Yeah, it's easy from one point of view. Sort of going back to empathy and thinking about where people are coming from. It's easy from one point of view to see and understand the argument. Okay, but if you just do it messy now and get something out the door, then we have met our deadline, satisfied our client, whatever the argument is. That's really easy to understand. It's harder to see, again, like a payday loan. You get the money now, you pay, 300% in interest. Later, that's a problem for later you. We want to make sure that we're not kicking those, like creating too many problems for later you, later us.
One of the things I think like is a good foundation for any like good code quality is healthy architecture. And part of that is making your code testable and writing unit tests. How strict do you like follow that rule of making sure that your code is both testable and writing unit tests for them?
I'm just going to confess that I'm terrible about writing tests. And I think it's a failing of the entire mobile industry that we don't test the way that other platforms and other code bases seem to. I always try and think about terms of like, is this code testable? And then never end up writing the tests for it. And the terror that I have felt trying to make changes in an untested code base and hoping nothing else has broken, I would rather write tests than deal with that. But
yeah, what do you think makes it such a big challenge?
You know what? I think it's a couple of things. I think fundamentally, I think there is a cultural problem, if that makes sense. It's like a systemic issue in the mobile industry that we aren't testing. Like a lot of people talk about the importance of tests, and then you go like poking in code bases, and there's not as many tests as people say there are or say there should be. Mm-hmm. I think partly that is driven by a lot of what we do is very profit driven. And I don't say that in like a, like let's discuss capitalism and its failings kind of way, but like we're trying to get products to market. We're trying, if we're in a startup, we're moving quickly and breaking things and don't necessarily have time to create the tightest, most tested thing before our funding runs out and we get something to market. Sometimes we're working in client services where trying to explain to a client why, this app that sells sandwiches is going to cost so much more than their website that sells sandwiches. And then also we're going to spend half of our time writing this test code that is going to like slow down deadline meetings and you can't see the value in it because you're selling sandwiches, not writing software.
Mm-hmm. It seems like there's a lot of experimentation too in the mobile industry to the point where like, why bother testing if nobody's going to use this app? That seems to be like a big part of it is like, let's just get retainment. Let's get people to actually like use our app first before we start talking about unit testing, which is unfortunate because I understand where they're coming from, but there are certain pieces of code that deserve to be tested that might not necessarily involve a lot of integration, but are just basic logic that you can at least start with when it comes to testing your code.
Yeah, there's always low-hanging fruit. I think I've seen a lot of projects fall into the trap of like, oh, we're going to start writing tests. We're going to write the simplest possible tests, most easily tested or easy to test bits. And then they never quite get to the hard stuff, to the, the more, possibly more important or more complicated tests that they may need to write. Or they may run into a situation where like, man, I thought it would be easy to test this code base, but turns out it's not. And it's going to be even harder now to write these tests. And
Right.
it's going to be an even harder sell to whoever is signing the checks to give me time to write these tests. I guess I'll do feature work instead.
And I think, like, at the very least, having an architecture where your code is easily testable, dependency injection, things like that is going to help a lot in making your code testable. And that goes back to that fancy word, which I will try to pronounce again, cyclomatic complexity.
Woo!
I think I did that right. That's a good indication. Like, if you have a lot of logic statements or a lot of lines of code in your function or your body, that's a good indication of like, A, your code is testable, and B, it's good quality.
Yeah, and I think one sort of really easy, like I said, there's no absolutes, but always choose the simplest solution to whatever your problem is. Your simplest architecture is going to be the easiest to understand. Your simplest solution is going to be the one that's easiest to come back to later. I think as an industry, like, code is fun. We can do really cool things with it. And I've never really lost the feeling that I'm doing some kind of like magic trick when I press a bunch of buttons and then something shows up on a screen.
Absolutely.
Like, that never goes away. And the sort of constant desire to, if this is a cool way to do it, then there's a cooler way to do it. Let's find the fanciest thing that we can do. Like, that's part of what's fun and exciting about code of any kind, mobile, web, other. You're telling a robot what to do. You're making something happen. That's really, really cool. Chasing that high can end up with us doing more and more complicated, sort of Baroque kind of things, both in terms of like architecture and the actual code that we're writing. Your point to something being over-engineered is almost worse than it being messy. Yeah, like we're constantly going after that. And I think that gets us in a lot of trouble. And, this goes back to not being able to test it because it's, very over-engineered, very like doing too many things at once, all of those bad code things.
Yeah, and it's like, I don't know, I haven't quite come up with a term for it, but the idea being like, code can be complex, but it's broken into as simple of its parts as possible. And like, that's really where the complexity belongs, is making sure that every little part is super simple, a simple little gear, simple little piece of machinery that does something very simple, but then it's the integration of all that becomes complex and making an app useful in the end.
Yeah, when I gave my talk at CodeMash on code quality, I very specifically wore a cable knit sweater. I've been knitting for years, and I have this really cool cable knit sweater that I wore. And in it, I make the point about simple and easy versus hard and complex. Easy and hard are relative. That sweater was easy. I've been knitting for 20 years. Yeah, it has a million braided cables on it, but that was no problem. It took me a couple of weeks. But it would take someone who was not as experienced knitting a very long time, and it would be very hard for them. It would be equally complex for both of us. Same number of stitches, same number of cables, same moves that you were making at the same amount of times. It was easy because I had a lot of experience doing that. It was just as complex for everyone.
All right. So we talked about unit testing. We talked about continuous integration, but I think we should get into automation. So I've been recently playing around with a lot of different code quality tools. I've been building basically Swift packages essentially, and been finding whatever stupid GitHub badge I can possibly find and adding it to my Swift packages. So I played around with a few of the tools. There's some like Code Climate, Hound, Code Beat, Code Factor, etc. And then there's, of course, Swift Lint and Swift Format. Those are probably more often used. And then there's things like being able to tell your code coverage for unit testing. How useful are those tools? What tools do you recommend integrating with your continuous integration that are actually useful to folks in knowing whether code is actually of good quality?
I mean, definitely a linter. You always, if you have more than two people on a project, you should probably have a linter because it means you have come to some agreement about what your code is going to look like. And then once you have those patterns, you can have expectations about when you're looking at new code that someone has added to the code base, that it's going to follow sort of expected conventions.
I would even do it if you have one person, especially with being able to tell the difference between two files. If one has an indent that's 2 spaces and one has an indent that's 4 spaces, making that the difference between two versions of a file is really annoying, to where if you integrate that early on a one-person project, those changes are gone. And then that way, the file history actually makes sense, as opposed to the file history taking notice of every stupid little white space difference.
Exactly. Yeah. That kind of consistency across a code base is, I mean, it's just one more thing you don't have to think about when you're looking at your code. One more sort of set of assumptions you can carry in, that it's all going to look a certain way and you're not going to hit any sort of like weird, why is that bracket there, speed bump when you're trying to comprehend something complex quickly. I'm a big fan of automated tools because it's always easier to have a robot tell you you're doing it wrong than have one of your coworkers tell you you're doing it wrong. Like a thing that flags, like the stupid linter that says, hey, you didn't cuddle your else the way we agreed we were going to, is, all right, fine, then I'll just fix that and that's no big deal and you go on about your life. If your coworker puts a little comment on every line that isn't indented correctly on a code review because we're trying to keep to a certain format, but we don't have a linter, now you've got the jerk who won't stop whistling in the office trying to tell you how to format your code. Like, it carries a lot of baggage, whereas a robot is just the automatic check failed, bah, 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 and you can fix it pretty easily and low stakes. In terms of like those CI tools that flag things like complexity and, you know, targets for refactor and stuff like that, same reason those are handy. You know, you don't feel a whole lot of ownership, or I don't know, doesn't have any of the baggage that a human being could have if they're pointing those things out to you. Right. But the danger with both a linter and an automated tool is that you can't automate human problems. You're still going to have to talk to your coworkers. You're still going to have to discuss, you know, an automated tool can tell you that this file is too long or that this method looks really complex, but it can't tell you an easier way to do it. It can't tell you that, yeah, that's an acceptable trade-off in this moment. And it can't tell you why we don't want long files or complex methods. All of those things sort of have to come from conversation. And using tools like that is great, but they should start with a conversation, especially if you're working on a team, a conversation with your coworkers about, what do you want this code to look like? What do you want? What kind of values about code do you want to have reflected in the code that you're writing and the code that you're committing? Even if you're just working by yourself and using tools like that, pour yourself a cup of coffee or a glass of whiskey or whatever it is that helps you think, and be thoughtful and considerate in the considering things sense. Be mindful of what decisions you're making and why you're making them. And don't follow certain rules because whoever wrote SwiftLint said that you should do it that way, and that's all the thought I'm going to give it. Think about why.
And also prioritize.
Exactly.
Yeah, and just prioritize and triage. Make sure like certain issues are very important and some issues are nice to have, but are not worth half your day trying to fix.
Exactly. One of those automated code tools can tell you, hey, this, you know, you should think about refactoring this file for these reasons. It's not going to tell you that this is going to be a source of bugs for you, given the work that is coming down the line and how you are going to be interacting with it in the future. It's also not going to tell you that, like, yeah, this is complex and it violates a whole bunch of rules and you should refactor it, but it's working fine. You don't touch it all that often. It's sort of isolated and isn't going to be interacting with any of your new features in a way that's problematic. So wait for, you know, the glorious day when we have infinite time to address all of the tech debt that has ever generated.
Exactly. The one I found was it would complain to me that I was using count. Mm-hmm. When in fact I was using, like, I had a variable name count where thought it was doing count with like strings. And so there's just all these like dumb issues it would find. The other one is like a duplicate code, which I purposely have in there because I want that flexibility, going back to what we were talking about before, to where in some cases I need to edit this in certain cases, and in some cases it needs to do a different thing, and I'd rather have duplicate code as opposed to refactoring it to the point where it's ridiculous.
Yeah, Dan Abramov had an article that came out, like, it hit all of the, like, Swift Weekly, Swift iOS Dev Weekly newsletters, like, 2 days after my clean code talk, and I wanted to send it to everybody. But it was called Goodbye Clean Code, and he's talking about an experience he had where he was working on a project that they were adjusting shapes for some reason. And there was a file that had, how to adjust this square, how to adjust a circle, how to adjust an oval. And he noticed that it was a lot of very repetitive code. So he refactored it to be much more flexible, have one thing that, took a bunch of parameters, thought he was going to get a million high fives for cleaning up this clearly messy code. And instead, his boss called him in and was like, so we're not going to merge this. And here's why. The reasoning was that, that code was repetitive, but it was clear and it was easy to read and it was easy to understand. And it was very specific about what it was doing. The sort of multi-purpose function that he wrote was much more complex, was able to do a lot of things, but was not very easy to understand. It's a great article. Dan Abramov's Goodbye Clean Code that I think is worth reading. But the premise of it, that the code that he was refactoring was not clean simply because there was duplication, is one that I kind of take issue with a little bit. Duplication isn't bad because it's fundamentally bad to have two of things. Everybody who's ever had a cookie understands that. But duplication is bad because, if you have
to maintain it twice as much.
Exactly. And if you have it scattered around, it's hard to find, and all of these different things. What he was looking at was a file that had repetitive code, but it was all in one place. So if you had to change one thing, everything you had to change was going to be right there anyway. And also, it was a bunch of math about adjusting geometry that was highly unlikely to change anyway. I would have argued that code was clean the way it was. His fundamental point, sometimes you have to sort of violate these clean code principles to have understandable code, I wholeheartedly agree with. But I would push back a little that code wouldn't have counted as clean just because it's duplicate. It's a smell to have duplicate code, but be thoughtful about why you're removing it and why people say, oh, you should avoid duplication. There's a reason for it. It's not an absolute. And a lot of what you have to do, like I said, it's longer and harder to write good, clean code than it is to slap something together. It's because you have to be more thoughtful about it. And using these tools that have sort of hard-coded in rules, those rules exist for a reason. And you should be thoughtful about what those reasons are and what those reasons are in relation to the code that you're writing right now.
Yeah, I think that's a really good way to put it. Is there anything else you wanted to talk about before we close out?
No, I think hit all the things that I had notes on.
Cool.
Yeah.
Yeah. I think the point being is that it's important to have, most importantly, ease of maintenance, ease of extensibility. It seems like when it comes to good code quality, having an architecture that's easily testable. While a lot of these automated tools are really great, especially the linters and formatters, it sounds like in the end, it's important to have some sort of like code review process.
Yeah.
And looking at things like Cyclomatic Complexity, which I finally was able to pronounce by the end of this episode, and, file length and things like that. And just don't over-engineer, which is often, I think, one of the bad habits we get into is wanting to refactor and over-engineer things to the point where it becomes difficult to maintain or difficult for some other developer to pick up on.
Exactly.
Well, thank you so much, Anne, for coming on the show. This was really good.
Thank you. I appreciate it. This was great.
Where can people find you online?
I am on Twitter, north of normal, north of normal on Instagram and GitHub, and just about everywhere that has a username, you can find me at north of normal. And if you want to argue with me about clean code, I'm in north of normal on Gmail too.
Awesome. And if you have any other feedback for the show, you can reach out to me as well. I'm at Leo G. Dion. My company is Bright Digit. Thank you, everybody, for joining us for this episode, and I look forward to speaking with you next time.
Thanks.